Alright, today we're going to look at finding the slope and rate of change. We're also going to practice graphing using slope-intercept form. So our vocabulary for today, we're first going to take a look at slope, which one thing I want to point out, slope and rate of change, they're the same thing. And you'll hear rate of change noted as ROC a good bit, just as shorthand, rate of change, so slope. And rate of change or slope, it's the ratio or the vertical change, which is rise, over the horizontal change, your run, between any 2 points on a line. So a lot of times we represent slope with the letter M, and you'll see that written as rise over run. So it's your vertical change over the horizontal change between 2 points. Now slope-intercept form is a very common form how linear equations are expressed, and they're expressed in slope-intercept form when it's y equals mx plus b. And m is your slope. So m is just the number. It's not the x coordinate, it's just the number. And that's our slope, once again, the rise over run. And b is our y-intercept. So we'll be taking a look at graphing in that form. Alright, so first we're going to find the slope of the line shown. Now to represent slope, once again I'm going to use the letter M, just to get in the habit of when we see M, we know we're talking about slope. So to find the slope of a line shown, you want to choose 2 points that fall on the grid. So I'm going to use these 2 points starred here, and you want this to make sure they fall on that grid point. And we're going to count the units that takes to rise and then takes to run. Now one thing with the rise, if you're going up, it's going to be a positive. If you have to go down, it's going to be negative. With your run, if you're going to the right, we have a positive value, and if you're going to the left, we have a negative value. Alright, so let's look at this. So to go from this point to that point up there, we go up 1, 2, 3, 4, 5, 6, 7. So since we go up 7, it's going to be a positive 7. And then we run 1, 2, 3, 4. So we run 4, and since we run to the right, it's going to be a positive 4. So our slope of this line is 7/4. For the next line for 2, once again we're going to do the same thing. We're going to pick 2 points that fall exactly on the grid. So the 2 points I'm going to use is that point right there, and then this point right here. Now once again, you can use any 2 points on this line because you'll get the same thing for your slope, but you want to use points that fall on that grid. So I typically start on the point that's lower, but you can start it either way, you'll get the same answer. So we go up 1, 2, 3, 4, 5, 6. So we go up, since we went up 6 units, it's going to be a positive 6. And then we run 1, 2, 3, 4, 5, 6, 7, 8. We run to the left. Now since we run to the left, we run left -8. Now one thing with slope, we always want to simplify it if we can. And 6 and 8 share a common factor of 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. And once again, that negative sign will go in front of that fraction. So our slope is -3/4. Now for 3, once again, pick 2 points on the grid. So I'm going to do that point and that point. So I go up 1, 2, 3, and I run no units. Now 3 divided by 0 is 0. So when you have a vertical line, your slope is always going to be 0. Now let's take a look at horizontal lines. For example, number 4. Take that point and let's come over to that point. So our rise, we go up no units, so our rise is 0. And then we run 1, 2, 3, 4 units. Now we're asking ourselves, how many times does 4 go into 0? We don't know. This is an undefined slope. So every time you have a horizontal line, your slope is undefined. Vertical lines, your slope is 0. Undefined lines, which are horizontal lines, your slope is undefined. We're going to find the slope and y-intercept of the following lines shown. Now, when we're finding the slope and y-intercept, it's going to be helpful with that form, y equals mx plus b. So our slope is the coefficient of x, or the number in front of x, and the coefficient of x, number 5, is 1/4. So our slope is 1/4, and our y-intercept is the constant, the number being added or subtracted from the term with x. And so 5 is our y-intercept since it's being added. Once again, 5, or your y-intercept is the constant. It's the number that's being added or subtracted. Now 6 is not in slope-intercept form, so we're going to write it in the form y equals mx plus b. So first I need to move the negative 5x over. So to add that I'll add it to both sides to cancel out. So I get 6y equals 5x plus 12. And then to isolate 6y, I'm going to divide y, or to isolate the y, I'm going to divide by 6 on both sides. So we get y equals 5/6x plus 2. And now we're in slope-intercept form, and we can quickly identify our slope, which once again is the coefficient of x, which is 5/6. And then our y-intercept is the constant that's being added or subtracted, and the term without the x value. So that our y-intercept here is 2. Now let's take a look at graphing an equation using slope-intercept form. Once again, slope-intercept form, y equals mx plus b. We want it to be in that form, y equals mx plus b. This one is not. We need to isolate the y. So to isolate the y, we're going to subtract both sides by 2x. So we get y equals negative 2x plus 3. Now once again, we're going to identify our slope and y-intercept. Our slope here is negative 2. Now since it's an integer, we want to think about it as over 1. So when you have a slope that's an integer, a whole number, or just a number, place it over 1. And our y-intercept is 3. So our y-intercepts, we cross the y-axis when y is 3. And our slope in negative 2 over 1, once again it's a rise over run. Since it's negative 2, we're going to go down 2 units and then to the right 1 unit. So we'll go down 1, 2, to the right 1. Now we also can take a look at this as positive 2 over negative 1, which is negative 2. So we also from that y-intercept can move up 2 units and then run to the left 1 unit. So we can go up 1, 2, left 1. So you can go either direction. And so that line, once again, we'll put arrows at the end. My face is blocking, that's the other side. We'll put arrows at that end. And so we connect those dots and fully extend it to meet the parameters of the graph. All right, the next equation, it's already in y equals mx plus b form. Our slope here, once again, the coefficient of x is 1/2. Our y-intercept is negative 5. So we cross the y-axis at 1, 2, 3, 4, 5. And then our slope of 1/2, so this is positive 1, we're going to go up 1, positive 2, we're going to go to the right 2 units. So up 1, right 2. You can continue to go up 1, right 2, up 1, right 2. Now in this case, we can also think of the slope as negative 1 over negative 2, because negative 1 over negative 2 simplified or reduced is positive 1/2. So we can also move down 1 unit and then to the left 2 units. So we can go down 1 unit, left 1, 2, down 1 unit, left 1, 2. And then you connect the dots with a straight edge, fully extend to the edges of your graphs, and draw arrows at the end. So that is how we graph an equation using the slope-intercept form. I will see you tomorrow.